I guess.
Hey, Jay! Cheers!
Hello, cheers.
So, what do you want to talk about today?
Computer networking, like in a super duper nutshell, because there's just so much stuff there.
What is it in a nutshell?
Is just an interconnection of different computers or devices like phones that are able to talk to each other using different protocols, using the internet and electric signals and whatnot, radio signals too, to transmit data between each other.
Can you tell me a little bit, what is a protocol?
Well, formal sets of instructions that dictate step by step how to do something. In networking, protocols would be in charge of dictating how the data would be prepared, transmitted, packed, unpacked. There's a lot of them. People came up with it just because it was at one point needed, right? World was evolving and World Wide Net was a thing. It's like, well, what do? We can't have a Wild West out there, because for this successful communication, we need very defined set of rules and agreement of how we're gonna be doing this. It's like if we both were speaking different languages, none of us would understand anything.
So can you give me some examples of what protocols do? I'm assuming they tell some kind of data to go somewhere, right? Get opened a certain way. Is that what I'm understanding?
Yes, but in that example you already described probably a couple of protocols, because it's not like one protocol does everything. So it packs and it transmits and it checks that was sent properly, it actually sends it physically. Like, that's a lot of different protocols that pass the baton to each other. All this baton passing type of thing is one layer of international model that pretty much most of the networking uses, the OSI model.
What is the OSI model and what are these layers?
It's more like an idea. Alright, we have so many things to do in order for the networking to be successful, for the communication to be successful between different devices. We have to encapsulate it as one big idea. All the OSI model dictates is that there's 7 different layers, and each of the layer is responsible for doing a very specific thing. To give an example, first layer, the physical layer. All that one is doing is making sure that the raw data, electrical signals or radio signals or whatever, right, that we're using is being successfully transmitted. That's all mostly it's doing.
And so far it sounds like layers have hierarchy, right?
In a way, yeah.
Talking about the first layer is just very basic physical transmission. Can you walk me through?
The first physical layer is just pretty much transmitting raw data. The second layer is the data link layer. All it's doing is making sure that the nodes, phone, computer, it's just nodes on the network. So that one makes sure that the communication between nodes now, not just through wires of raw data, is being done. The next layer is one of the most important ones at this point, I guess, because it's the internet protocol, the network layer, which that's where the IP is. That's where we get into transmitting data in packets over the internet, wider networks and everything. Fourth layer is the transmission layer. That one dictates how data is being sent.
But how? Do you mean there's different options or something?
There is. Like, there's 2 main ones that's being used, TCP and UDP. TCP standing for Transmission Control Protocol, and UDP is User Datagram Protocol. The whole point...
What am I using in my apartment right now?
Probably both. It depends what you're doing. The Transmission Control Protocol was developed to ensure no data loss, both sides complete a handshake. Meaning that, yeah, they first establish, like, do you want to talk? Yes, I do. Well, let's do it. And then it starts. So it checks the data that it hasn't been lost, over the transmission. TCP is what, let's say, if you want to send a photo to somebody, you want that photo to come in the same shape as you sent it.
So it all feels like very important stuff. What's the other thing not doing that?
The UDP one?
Yeah.
It's transmission without that handshake.
Forcing the photo?
Exactly. It's just being like, hey, I'm sending you stuff. I don't care if you get it, but here you go. And
why would you want that?
Well, how about the phone? You're talking over the phone to somebody. What do you prefer? The thing is, with TCP, the Transmission Control Protocol, there's an overhead of checking everything, so it takes time. It might take milliseconds, but it really matters if you're talking over the phone.
Yeah. Voice over internet? Is that it?
Yes. Okay. Streaming is also a UDP. You do not care if by any chance, the quality drops a little bit on that part of your screen. So, like, you just want consistent sending of data without an overhead of double checking and send it back and forth. Okay. That's why UDP is usually used.
Nice. What's the next layer?
Next one is the session layer. It's almost a part of the transmission layer protocol, especially with TCP. When you have that handshake, you create a session in a way. Oh, we agreed to do our stuff. Well, what happens when you stop doing your stuff. Is that connection still open? How do you sever it? So that's what the session layer governs, like how to gracefully end the connection. Next one, the sixth layer, is the presentation layer. All it does is make sure that the data that's being prepared is done properly by the application, because that's our final layer.
Apps, right? The apps on our phone?
In a way, it's not like apps. There's protocols in the application layer that your apps might be using, but it's not like layer 7 is the apps. It's protocols like HTTP, and that's what you usually use to browse internet.
Yeah.
So that's like the very tip of the iceberg at that point. That's where the process starts of how to create that packet of data.
Top?
It starts on the top, and here's where it all comes together. That's why they are called layers, because it starts at the top with the application where it's like, okay, I need to send something and I need to make this packet of data. So in the application layer itself, makes its packet with the information from the application layer and passes it down to the next layer. And it's going down like a waterfall, and guess what? The data, the header that was made in the top layer gets passed down and gets wrapped around into layer 6 information. And that goes down, wraps around in layer 5 information. So forth, until guess what? Bingo, it makes sense. You get to layer 1, which is the actual transmit the thing. On the other side, it's just gonna receive that encapsulated packet, and it's just gonna open it up the same way, but up.
Yeah.
Like,
so, you know, it's a big world.
yeah, it's rather big. You're right.
So for computer networking to happen all over the world at this point, no matter what country you go to and no matter what device you have, everything's using the 7 layers, right? That's the model for how you communicate between computers.
I'm pretty sure there might be some experimental stuff that doesn't, but commercial uses and probably, you know, of course military too, they pretty much adhere to this. They have to, because otherwise it's our agreement on how to communicate. If one side doesn't do it, it's not gonna work.
What's an example in a non-digital life? Like having a metric system, so we all, like scientists, know that what measurements are?
Actually, exactly. OSI Model, that's a really good point. That's where scientists decide that's like, okay, let's all agree that we measure distances in meters, of course kilometers, like, oh, we measure temperature in Kelvin, right? Because that's the OSI model. If you don't do that, and I'm pretty sure there were stories where that happened, scientists from all over the world were working together, and then the project failed miserably because one side was working with feet and the other was with meters, and they didn't communicate with it.
So, Jay, what would you like to learn more about?
I heard a lot about quantum computers. I don't really know how they work, and it seems crazy and fascinating because I know that our computer are just working on binary, pretty much machine code. Zeros and ones, exactly. So quantum works differently.
What do they use?
That's exactly what I want to find out. It seems like they still use zeros and ones or some quantum cells that could be on and off at the same time. It's crazy. So that's why
0 or 1?
Or both at the same time. That's the whole quantum mumbo jumbo. If someone could explain something like that, like in simple terms, I would be really happy to learn.
Hey. На здоровье.
На здоровье. Hey.